everyone. My name is Quentin Monnet. I've been working at Netronome and with BPF for some time now, maybe a couple of years. I try to contribute in order to make things a bit easier to work with, for newcomers to get started with BPF, with some other people as well. And so I'd like to pursue in that direction today by presenting, well, mostly triggering a discussion about the eBPF debugging infrastructure. So first thing is for me to explain what I mean by debugging eBPF. It's not debugging the kernel with eBPF. Instead, it's debugging everything related to the workflow for working with BPF itself. Then I will present a very, very brief overview of the tools that we already have to work with BPF and to debug each of the stages. And mostly I would like to highlight what might be missing to make this toolset more comprehensive and to see if other people here agree or have other ideas about things to add to the set. So most of you are familiar with the workflow already. So usually you start to compile your program from C into eBPF bytecode, then inject that into the kernel where it passes a verifier. And if everything goes well, you get to attach your program to one of the hooks in the kernel and to run it, for example, to process packets. This gives us a bunch of different stages at which we want to see what's happening and to debug stuff. So at compile time, when I'm turning my C program into BPF bytecode, then we have a second block at load time when I want to understand why the verifier doesn't want my program in the kernel. At runtime, obviously, if the program does not behave as I expected, we have other two blocks that are related also. So for kernel development, for touching the BPF infrastructure to make sure that we don't break the existing things. In user space programming as well, when I'm trying to create a project based on BPF, using BPF system calls, how can I debug this, make sure that the system calls are used as I expect. So I start with the compile time blocks. So I don't have that much to say on this one. What I want to do is to make sure that my C program is compiled into the expected instructions. So what I have is mostly the LLVM backend client to turn my program into BPF. I do have a couple of utilities here coming with LLVM mostly to check that the instructions are as I expect. So LLVM objdump makes me able to see the generated instructions from my L file. I also have now an eBPF assembly that can be used to first compile from C into this assembly language, which is similar to what the verifier prints. And then I can hack this assembly, which is more easy to read than just hexadecimal bytecodes, and then compile that again into BPF so that I'm sure I get the right thing into my L file. So once I've compiled my BPF bytecode, I want to inject that in the kernel. If everything goes well, I've done my program properly, it passes the verifier, or otherwise, which happens quite often, especially at the beginning, I get rejected by the dreadful verifier, which doesn't help that much when you don't understand the messages that it prints to the console. So we have a bunch of programs used again here. So IPTC for loading programs, eBPF, which can be used to bpftool for loading programs of non-networking related types. The good thing is that we get one more output into the console instead of, for example, kernel logs. We get them in the verifier log in the console when I'm trying to load the program. We get extract messages when I try to attach the programs. We do have some documentation now, so some documentation has been in the kernel sources from some time now. It's somewhat outdated, not too much. Well, I mean, that could be worse, man pages, for example. But we do have the CDM guide, thanks to Daniel mostly, which is a really, really good source of documentation for everything related to BPF. So it helps a lot understanding what's happening. But maybe we could have something more. So, for example, we could imagine extending bpftool with a new feature, a new command to, for example, to probe an object file, an ELF file, in order to see what sections, what programs in what sections do load and what do not load into the kernel. So that's an idea by Daniel. So I started to work on that. Maybe there's more to do than just program and sections. So that's an idea to explore. Jesper had done some work also in the tests at some point. So we have those man pages for the BPF system call also for TC BPF, which are so badly outdated really. There's not half of the BPF subcommands in them, so we'd like maybe at some point to give a pass, and then maybe more of a pass, and to update them as much as we can. We could also imagine creating FAQ with messages from the verifier. We already have some in the kernel document, filter.txt. Like, I get this message, what does that really mean? Because the message holds on one line in my console. I don't always understand it correctly. Can I get more feedback, more input, and more explanation about what usually this error means? And also for other messages not coming from the verifier at other steps, for example, extract messages that might not be clear enough. I don't know, can I get more information somewhere centralized? That could be a lead. So now say I have loaded my program into the kernel, I attach it to DC, XDP, whatever, and my program does not pass my packets as I expected, so there's something wrong with my program. What happens? At this time, I don't have a real BPF debugger existing, so we have a couple of utilities existing, bpftool to dump the instructions loaded into the kernel, BPF instructions or JIT compiled native instructions. We have helpers such as trace printk, which acts like a printf helper, which is really useful for debugging until you start working on BPF offload, where it's not supported, but then you get perf events, which allows also to get some feedback. Maybe something close to a debugger is that we have some user space eBPF machines existing, but they don't support nearly as many features as in the kernel, and it's quite limited. So we do have some support started by David Miller, I think, some time ago, for working in Binutils GDB with BPF, but there's no simulator part, so we cannot run step-by-step a program with that at the moment. We do have something for CBPF, which is in the kernel sources by Daniel, but it does not work with eBPF, so that's quite limited today. So the idea that I would like to work with eventually, or see if other people are interested to work on, is to create something that would allow you to run a program step by step, or if not step by step, at least to insert breakpoints so that you can, at some given instructions, dump the content of the registers of the BPF stack, possibly of the context, so packet data, whatever I'm running my program on. So we have maybe some leads on that, completing the support in GDB, or maybe seeing if something is doable with LLDB. I don't know that really well, so I don't really know if that's possible. In any case, I'm not sure how we could, for example, pass packet data to a program running in GDB. That's quite different from a C program that I'd like to debug. So maybe one thing to explore, suggested by Daniel, is to extend the BPF probe test run infrastructure that is in the kernel already. So that's something you can pass information to, you can pass a program to, and you give it some input data, it gives you some output data and the return value. We could imagine adding attribute there to add breakpoints to that infrastructure. So, so my program is running correctly, that's good. If I want now to add new features to the kernel, I get other things I want to check. So we have a bunch of self-tests for the verifier, for some core BPF features among the kernel testing infrastructure. We have sample programs too that should still be compiling after everything has been changed. We have the BPF probe test run infrastructure. So and test with the kernel address sanitizer with syscaller, which runs a whole bunch of tests periodically on the kernel, including on BPF parts. So that's good to have. But for example, we could also imagine trying to, instead of just JIT compiling one program for my architecture, I could be willing to generate the images for all existing architectures, so all existing JIT compilers, which would then have to be built in the kernel instead of depending on the architectures, and generate those images, dump them to the users so that we could check that for every architecture, everything has been compiled properly, and then possibly just after that trigger a simulation for each given architecture of the program to check that it runs correctly. So that's also something to explore. And the last block is about user space programming. So I have one project using BPF system calls. It can be Cilium, it can be Suricata, it can be whatever program is calling BPF to load programs to manage BPF maps and so on. So we do have support for strace, valgrind, for tracing the system calls or for checking memory, for example, for the BPF system call now. We could also imagine adding some new features, not directly related to the system call, but something, for example, to check, to probe what's available on the kernel I'm running. So that's something I've discussed with Daniel again, because Cilium tries to probe the kernel for a number of features. For example, I want to use this given BPF helper. Does the kernel support this? Or is my kernel too old? Or maybe I just don't have the good configuration option set at compile time. So is that feature supported? That's something that we could maybe add to bpftool. Actually, I've been working on this over the last days, so it should be ready at some point to provide checking for maps, map types, program types, helper types, a bunch of other parameters. And I'd like to see also if you have some other ideas of things to check at this stage. We could also imagine that the last thing that I propose here, new ways to generate BPF bytecode. So for example, we have libpkep used to with tcpdump to generate from source port equals SSH, something like this, to generate C BPF, the legacy BPF corresponding program. Maybe we could use that for doing the eBPF2. We have also the if tool and tuples filters for filtering traffic on the receive side that uses a specific syntax that I'm trying to use also to generate BPF programs, so that we could make it easier for users to get started with BPF and to generate the first programs. So that's it for this presentation. I'd like to see if you have other ideas that would be worth adding to the debugging infrastructure. So if you have questions or suggestions, they're welcome now. Thank you.
Yep.
I'm going back to slide 5. So this is the compilation, maybe kind of steps.
Is this one?
5.
5, sorry.
Yes, so let's see. So one of my thoughts was for the troubleshooting. So it's great to have like really awesome docs, but if nobody actually knows how to find them, then that's not super useful. So like one maybe super minor suggestion we could do is like if there was a particular error in the kernel that the verifier returns, maybe we can actually attach like a link there, like some bit.ly, whatever, and that would link to some documentation page which can actually explain like this is how, like if you hit this error, like here's how to find more information, something like that.
So you mean everyone that gets a particular error that they have trouble with get to contribute and to add a message about that?
So like you load your BPF program, it comes like some error comes back, it's like a fixed string from inside the kernel. We just return like a link there as well. So we don't have to like document the entire thing inside the kernel tree, but it just has a link to somewhere where we can write better docs.
Yeah.
So then you don't have to like
That's a good
try
idea.
and figure out where to get it from.
Yeah. Thank you.
So regarding the compilation and the verifier stuff, so what we've been actually trying to do, so soon we'll have the source line info information for debugging purposes. So one of it is just debugging, but the bigger part of it is to make verifier errors readable to humans, because the source now will be passed to the kernel, so verifier can not just say, here's the verifier output and the BPF instructions, and well, here are this registers that's underneath. It will actually print the source code line and say your line 5 in your C code, and that was the source code from that. So that should, I think.
Yeah, that sounds absurd.
Hi, I have a quick thing about runtime debugging that I'm really happy you mentioned strace, that I always have this thought, which is like the BPF helper calls is just like BPF making syscalls. So if we can make something like a BPF strace that I can provide a program ID and you can show me all the helper calls like map lookups or like other help like SKP operations calls, like what arguments provided, what returns value it gives, and stuff like those. It could be very, very helpful in most of the case in our debugging. And you know, like now with BTF, we can even like pretty print all the map keys and values and stuff like those. And it doesn't even need to do complicated work on compilation JIT time. Do you think that's possible?
I think it's a good idea. So those BPF helper calls, if they're not inlined, then you could also trace them, right? But you would have to have some additional information what program is currently running, which we currently don't have, right? But I think it would be useful. It would be super useful.
Right. In the old days, I've did like trace the PY on some of the BPF calls, but now there are so many BPF programs running on the machine, it's hard to distinguish.
So, yeah, definitely something worth exploring. Thank you.
So I have one more comment for the last slide. Yes, so I think here that the question about probing for kernel features came up so many times in the past, in particular from Jesper and many others. So I think this idea like sounds particularly the most appealing to me. If we can have like eBPF and bpftool to have any number of like feature requests, like part of it can be just saying like, bpftool, give me a list of bound defines for this given kernel, what's available. Like it will say, yeah, that XDP is available here, or bounded loops are available on this kernel. Just like query the given kernel on demand. And you know that the eBPF can have this query functions on demand as well. Like part of the eBPF can be a function to say, is this if index 5 supports XDP and supports a direct, and then it can go like prop stuff dynamically and everything just like all the magic underneath.
Yeah, I think this will be super useful because every project will have this problem, right?
Yeah. So yeah, I really want to see that. But how are you going to implement that? Are we going to like have to probe the system call if this helper is available, and we have to make a small program that we load in the syscall?
And the idea that it all like will be hidden by eBPF, it will have this pre-canned probing like Cilium does. And we'll just like move it into this eBPF and hide it by the.
I really like it, but what I don't like too much that we are probing so many times the syscall for every and.
Well, yeah, it should be really done once or whatever in the beginning of it.
Because we are going to look like 100 syscalls to figure out what this kernel supports or more.
But I mean, you would do that usually. But I think it would at least be a good start.
So would it be possible to move a verifier collection into user space, and then we could run the verifier for every single kernel version that we want to target that avoids the syscalls for checking features, and we're going to have some definitive list of stuff where the eBPF object is going to work?
I mean, verifier collections probably. But where would you have it, like in the kernel tree, or? I mean, probably what you could do is to have the verifier compiled out of user space and out of the kernel, but still living under kernel BPF, right? Like we do with the dissector.
Because
like
at
a
the
whole collection, I don't know. It's tricky.
Because at the moment, if I'm targeting multiple kernel versions with the same BPF object, then I still need to run every single kernel version to actually run the verifier on my object. and because the verifier evolves, the supported features might differ. I don't know what the right place is to put this, but it would definitely be useful in development time.
Yeah, thank you. Point taken. I think we are about 2 minutes over, so
Thank you very much.
Thank you.
yeah, let's continue. Thanks.